Okay, so you want to own a DNS provider, a handful of servers scattered across data centers worldwide, quietly answering a question billions of times a day, translating a domain name a human can remember into the numerical address a computer actually needs, and collecting a recurring fee for a service most of the internet's users have never even heard of. You picture yourself as the invisible plumber of the internet, running one of the most essential, least glamorous businesses in all of technology. That's the fantasy. Here's the actual business hiding underneath it, an industry where the core technical function is so simple it can be, and often is, given away completely free by some of the largest companies in the world, where a single misconfigured record or a single distributed denial of service attack can take down not just your own customers, but a meaningful share of the visible internet. And where the entire premium tier of this business depends on convincing customers to pay real money for something that, at a basic technical level, a free alternative can do almost as well. Some DNS providers have built genuinely durable, high-margin infrastructure businesses serving the world's largest companies. Others have been rendered functionally obsolete by the same cloud computing giants who now offer DNS as a nearly free add-on to services customers were already buying anyway. By the end of this, you'll understand exactly why DNS is one of the strangest businesses in the entire internet infrastructure stack, genuinely mission-critical, genuinely difficult to do exceptionally well at scale, and simultaneously, one of the most commoditized, margin-compressed corners of the entire technology economy. What you're actually buying before the money makes sense. You need to understand what the domain name system actually does, and why that specific function creates such an unusual business. Every time anyone types a website address or an app makes a connection to a server, that human-readable name has to be translated into a numerical IP address before any actual data can move. And DNS is the distributed, hierarchical lookup system that performs that translation, a genuinely foundational piece of internet infrastructure that virtually nothing else on the internet functions without. This creates a business with a peculiar dual nature. At its most basic level, authoritative DNS hosting, simply answering lookup requests for a domain's records, correctly and reliably, is a commodity service with minimal technical differentiation between providers, which is exactly why the largest cloud computing platforms, Amazon, Google, Cloudflare, and others, offer basic DNS hosting for free or at costs so low, they're essentially a customer acquisition and retention tool for their broader, more profitable cloud services rather than a standalone profit center in their own right. But layered on top of that basic lookup function sits a genuinely differentiated, defensible premium tier, DNS providers that offer superior global network performance through points of presence strategically distributed to minimize lookup latency anywhere in the world. Sophisticated traffic management features like geographic routing and automated failover that large enterprises genuinely need and will pay for. And critically, DNS-specific security services, protection against the distributed denial of service attacks that specifically target DNS infrastructure as a way to take an entire company's internet presence offline. Since if an attacker can successfully overwhelm the DNS servers answering lookups for a company's domain, it doesn't matter how robust that company's actual web servers are. Nobody can reach them if their domain name can't be resolved in the first place. This is why the DNS business essentially bifurcates into two genuinely different markets: a commoditized, often free basic tier that exists mostly as a loss leader or bundled feature within a broader cloud platform, and a premium, security and performance-focused tier serving enterprises for whom DNS reliability and attack resilience represents a genuine, mission-critical business risk worth paying real money to manage. The cost of actually building the thing building genuinely competitive. Enterprise-grade DNS infrastructure acquires substantial upfront and ongoing investment, even though the core technical function itself is architecturally well understood. According to industry analysis of content delivery and DNS infrastructure economics, building a globally distributed DNS network, with points of presence capable of answering lookup queries. With low latency anywhere in the world requires establishing server infrastructure across dozens of geographic locations, either through owned data center space or through colocation and peering arrangements with existing internet exchange points. A network build-out that a serious global DNS provider commonly measures in the tens of millions of dollars before accounting for the ongoing operational cost of running it. Network peering and bandwidth represent a substantial and somewhat unusual cost category specific to this business, since a DNS provider needs not just server hardware, but genuine, high-quality network connectivity to internet exchange points and major internet service providers worldwide, and establishing the kind of peering relationships that allow traffic to move efficiently, rather than taking indirect, latency-adding routes, requires both technical negotiation and often direct payment for premium network transit in regions where a provider doesn't have sufficiently established peering relationships of its own. Anycast network architecture, the specific technical approach nearly all serious DNS providers use, where the same IP address is announced from multiple physical locations simultaneously, and internet routing automatically directs each query to the nearest available server, requires genuinely sophisticated network engineering talent and specialized routing infrastructure to implement correctly. And getting this architecture wrong doesn't just create a performance problem. It can create genuine reliability failures during exactly the high traffic or attack scenarios when the system needs to perform best. DDoS mitigation infrastructure, the capacity, specifically over-provisioned, to absorb and filter malicious traffic volumes during an actual attack, represents one of the largest and most specialized ongoing capital investments in this business. Since a provider needs to maintain network capacity substantially exceeding normal operating requirements, specifically, to remain available during the exact moment a determined attacker is trying to overwhelm that capacity, meaning a meaningful share of a serious DNS provider's total infrastructure investment exists purely as insurance against an attack scenario that, on any given day, isn't actually happening. The race to zero. Here's the structural dynamic that has reshaped this industry more than any other single factor over the past decade, and it explains why so much of the basic DNS hosting market has effectively become worthless as a standalone product. Major cloud computing platforms discovered that offering DNS hosting for free, or bundled at negligible cost alongside their broader cloud infrastructure services, functioned as a genuinely effective customer acquisition and retention strategy. Since a customer who hosts their DNS with a specific cloud provider faces real switching friction, however modest, that makes them somewhat more likely to also purchase that same provider's compute, storage, and other cloud services, rather than mixing providers across every layer of their infrastructure stack. This competitive dynamic has pushed the price of basic, authoritative DNS hosting toward essentially zero across a substantial share of the market, since a paid, standalone DNS provider, offering nothing beyond basic lookup functionality is competing directly against providers who have every incentive to offer that exact same basic function for free as a loss leader. For a more profitable relationship elsewhere, a genuinely difficult competitive position that has forced the independent, standalone DNS provider business to either move decisively upmarket into the premium security and performance tier discussed earlier, or accept operating in a commoditized segment with minimal, any standalone profitability. According to industry analysis of internet infrastructure business models, this dynamic mirrors a pattern that has played out across several other foundational internet technology categories, where a core, architecturally simple technical function becomes commoditized and effectively free once it's incorporated as a feature within a broader platform's ecosystem, while genuine, defensible profit migrates specifically to whatever adjacent capabilities, security, performance optimization, specialized enterprise features, remain genuinely difficult to replicate and genuinely valuable enough that sophisticated customers will pay a premium for them even when a free basic alternative technically exists. This is precisely why the DNS providers that have built genuinely valuable, durable businesses over the past decade are overwhelmingly the ones that positioned themselves explicitly around security and performance rather than attempting to compete on basic hosting alone. Since basic hosting, as a standalone business, has been effectively strategically destroyed by the economics of the broader cloud platforms that offer it as a loss leader, how the money actually comes back. Revenue models among the DNS providers that have built genuine, durable businesses reflect this bifurcated market structure directly. According to industry pricing data and public disclosures from companies operating in this space, enterprise DNS and DNS security services are commonly sold through tiered subscription pricing based on query volume, the number of individual lookup requests a customer's domains generate, along with premium pricing for specific enterprise features like advanced traffic management, service level agreements guaranteeing specific uptime and latency thresholds, and dedicated DDoS mitigation capacity, with serious enterprise contracts for large, high-traffic domains commonly running from tens of thousands to well over $1 million annually, depending on traffic volume and the specific security and performance features included. Many of the industry's most successful providers have built their DNS security offering specifically as part of a broader content delivery network and web application security bundle, recognizing that DNS security, protection against attacks targeting the domain lookup layer, and broader web application security, protection against attacks targeting the actual application and server layer, address related but distinct parts of the same underlying customer concern, meaning a customer already purchasing broader security and performance services from a provider presents a naturally receptive audience for that same provider's DNS-specific offering. A cross-selling dynamic that has become one of the more important revenue drivers for the industry's largest players. According to public financial disclosures from companies in this broader infrastructure security space, gross margins on these premium DNS and infrastructure security services commonly run extremely high, frequently 70 to 80% or more, reflecting the reality that once the substantial upfront network infrastructure has been built, the marginal cost of answering additional legitimate lookup queries, as opposed to the substantial cost of maintaining standing capacity against potential attack volume, is genuinely quite low, a cost structure that rewards providers who can achieve genuine scale across a large enough customer base to spread that substantial fixed infrastructure investment across meaningful recurring subscription revenue. The volatility nobody wants to talk about buy-in. The basic commoditization pressure already discussed. DNS providers carry several distinctive operational risks. Attack volume and sophistication risk represents a genuinely acute, ongoing vulnerability specific to this industry, since distributed denial of service attacks targeting DNS infrastructure have grown considerably in scale and sophistication over the past decade. And a provider whose infrastructure investment hasn't kept pace with the genuinely escalating scale of the largest attacks being carried out across the broader internet risks a public, highly visible outage precisely at the moment its DDoS mitigation capability is most tested, a reputational and customer retention risk considerably more severe than an equivalent capacity shortfall in almost any other type of infrastructure business. Since a DNS outage doesn't just degrade a customer's service, it can make that customer's entire internet presence completely unreachable. Single point of failure and concentration risk represents a genuinely significant structural vulnerability for the broader internet that specifically threatens the reputation and business viability of any individual provider that experiences it. Since when a single major DNS provider suffers a significant outage, the resulting disruption frequently affects a large, visible share of major websites and services that happen to be customers of that specific provider simultaneously, generating the kind of widespread, headline-making internet outage coverage that can meaningfully damage a provider's ability to win and retain large enterprise customers going forward, even if the underlying technical failure was a genuinely rare, difficult to prevent edge case. Customer concentration and price competition risk affects the economics of this industry considerably, since the largest, most sophisticated enterprise customers, the ones generating the highest margin revenue in this business, also carry the most negotiating leverage and the most realistic ability to threaten migration to a competitor or to bring DNS management in-house entirely, meaning a meaningful share of a DNS provider's most valuable revenue relationships face genuine, ongoing pricing pressure precisely because those customers are sophisticated and technically capable enough to credibly evaluate alternatives. And regulatory and geopolitical risk has become an increasingly relevant consideration for this industry, since DNS infrastructure sits at a genuinely sensitive intersection of internet governance, national security, and international politics, with several governments over the past decade pursuing policies around data sovereignty and infrastructure localization that have meaningfully affected how global DNS providers structure their international network architecture and customer contracts in specific jurisdictions. The real case study, the 2016 DNS attack, to understand how catastrophically a DNS-specific attack can cascade across the broader internet. Look at what happened on October 21, 2016, when DNS, at the time one of the largest managed DNS providers serving a substantial share of major internet companies, suffered a series of massive distributed denial of service attacks that disrupted internet access to a significant number of major websites and services across the United States and Europe for much of the day. The attack was carried out using a botnet called Mirai, a network of compromised Internet of Things devices, security cameras, home routers, and other internet-connected consumer devices infected with malware that allowed attackers to direct enormous coordinated traffic volumes at a target, and according to subsequent technical analysis and security industry reporting on the incident, the Mirai botnet directed traffic volumes at DNS infrastructure that were, at the time, among the largest DDoS attacks ever publicly documented, a scale that exceeded what DNS existing mitigation capacity had been provisioned to absorb. Because DNS served as the authoritative DNS provider for a substantial roster of major companies, the resulting outage didn't just affect DNS directly, it made a significant number of major websites and online services, companies whose own servers and applications were functioning perfectly normally throughout the incident, completely unreachable for millions of users for extended periods throughout the day. A clear, highly visible demonstration of the single point of failure risk discussed earlier. Since from an ordinary internet user's perspective, dozens of seemingly unrelated major websites simply stopped working simultaneously, when the actual failure point was a single shared DNS provider several steps removed from any of those companies' own infrastructure. The incident triggered substantial reassessment across the technology industry regarding DNS infrastructure resilience, with many major companies subsequently adopting multi-provider DNS strategies, deliberately using more than one DNS provider simultaneously specifically to eliminate the single point of failure risk. The DNS incident had demonstrated so publicly a direct, structural response to this exact vulnerability that has meaningfully reshaped how sophisticated enterprise customers approach DNS infrastructure planning ever since. The attack also prompted significant industry and regulatory attention toward the broader security vulnerabilities of poorly secured Internet of Things devices, since the attack's enormous scale was made possible specifically by the sheer number of inadequately secured consumer devices that had been compromised into the Mirai botnet, a security failure entirely outside DNS's own infrastructure that nonetheless directly caused DNS's outage, illustrating a genuinely uncomfortable structural reality for this entire industry. A DNS provider's own infrastructure and security practices can be flawless, and it can still suffer a catastrophic, business-threatening outage caused entirely by external attack capacity that has nothing directly to do with any mistake the provider itself made. A risk category considerably harder to fully insure against than the kind of operational or financial risks that dominate most other businesses examine throughout this series. 2 scenarios. Let's build the honest math, the way an actual owner has to run it. In the good scenario, you own a DNS provider that has successfully positioned itself firmly in the premium security and performance tier, serving large enterprise customers who value and are willing to pay substantially for genuine DDoS resilience, global network performance, and the kind of service level guarantees that basic free DNS hosting simply cannot match. Your infrastructure investment in DDoS mitigation capacity has kept pace with the genuinely escalating scale of the largest attacks occurring across the broader internet, meaning your business has avoided the kind of headline-making outage that could meaningfully damage enterprise customer trust. And your revenue is increasingly bundled within a broader security and content delivery platform that creates genuine switching costs and cross-selling opportunities beyond DNS alone. At the extremely high gross margins this business can support, once genuine infrastructure scale is achieved, a well-positioned premium DNS and infrastructure security provider can generate an attractive, durable, recurring revenue business with genuinely defensible competitive positioning against the free basic tier alternatives that dominate the commoditized end of this market. Now, the harder scenario. You own a DNS provider that built its business primarily around basic, authoritative hosting without successfully differentiating into the premium security and performance tier, competing directly against major cloud platforms who offer that same basic function essentially for free as a loss leader for their broader, more profitable services. Your infrastructure investment in DDoS mitigation capacity has not kept pace with the escalating scale of attacks occurring across the broader internet, leaving you genuinely vulnerable to exactly the kind of large-scale, coordinated attack that overwhelmed DIN in 2016. And a single significant outage event, whether from an attack your infrastructure wasn't provisioned to absorb or from a technical failure in your own network architecture, generates the kind of reputation-damaging disruption to your customers. Businesses that can trigger a wave of enterprise customer departures to competitors or to multi-provider strategies specifically designed to avoid single-provider dependency going forward. The gap between these 2 scenarios isn't a modest variance in a competitive positioning strategy. It's the difference between a genuinely durable, high-margin infrastructure business and a company competing in a segment of the market that the broader economics of the cloud computing industry have already rendered close to unprofitable. As a standalone business, the real payoff, the difference between DNS providers that have built lasting, durable value and those that have been rendered functionally obsolete by the broader cloud computing industry's economics, comes down to a small number of disciplined strategic choices, recognizing clearly and early that basic authoritative DNS hosting has been effectively commoditized to the point of near worthlessness as a standalone product, and building a business explicitly around the premium security and performance capabilities that remain genuinely defensible instead, has proven to be the single clearest differentiator between DNS providers that have built durable, high-margin businesses and those competing in a segment the broader market has already strategically destroyed. Maintaining genuine, ongoing investment in DDoS mitigation infrastructure that scales ahead of, rather than merely alongside, the escalating attack capacity being demonstrated across the broader internet matters enormously in an industry where a single catastrophic outage, as DIN's 2016 experience demonstrated with genuine clarity, can meaningfully damage years of accumulated enterprise trust in a single day, regardless of how well the provider's underlying technology otherwise performed. And building genuine cross-selling relationships within a broader security and content delivery platform, rather than treating DNS as an isolated, standalone product competing purely on its own technical merits, provides real insulation against the commoditization pressure that has made pure-play basic DNS hosting an increasingly difficult standalone business to sustain. The romance of running essential internet infrastructure, the quiet, invisible plumbing that makes the entire internet function, is genuinely real, and it's precisely the providers who have built genuine, defensible value around security and performance. Rather than attempting to compete on a basic function that major cloud platforms now give away for free, who have built something durable in an industry where the core underlying technical function has been effectively rendered a commodity, which means the honest answer to whether owning a DNS provider can build genuine, lasting wealth is yes. For the providers disciplined and strategically positioned enough to have moved decisively into the premium security and performance tier, this industry's economics increasingly demand. But for a provider still competing purely on basic hosting functionality alone, the honest answer is that the broader cloud computing industry's own competitive strategy has already made that specific business considerably harder to sustain than it once was, regardless of how well that provider executes its own basic technical function. And subscribe to my channel. Thank you.